Okay, so today I have a guest with me that's we're going to talk about AI agents, and they have a product called AgentOps. And here with me is Alex Friedman. And if you'd like to go and introduce yourself.
Hey everyone, my name's Alex Friedman. I'm the founder of AgentOps. Agents suck. We're fixing that. Right now, they're slow, they're expensive, and they're unreliable. And that's largely because the tooling around agents is very immature right now. It's hard to see what's going on. It's hard to see how much they cost. It's hard to actually go back in time and understand how we can affect and change the logic of the agents and make them faster, safer, and more reliable. So that's what we do with AgentOps.
Okay, awesome. So, kind of what I feel like you're saying is that whenever we, have a simple AI agent setup, whether using AutoGen or Crew AI, sometimes you don't really know what's happening. You get the output that you hope to get from your prompting with the agents, but this kind of give you more visibility to a lot more of the metrics. Would that be correct? What you're saying?
That's exactly right. So one big issue when you're debugging or just building AI agents in general is that they're extremely yappy. That means that they produce a lot of output tokens. So if you're trying to read through your logs, it's next to impossible. Your terminal window is going to get spammed with text, and it's one of the most frustrating processes possible. For context, we started developing agents early 2023. Our first agent
Mm.
was a data entry automation agent. So what it would do is to take data from PDFs and emails and spreadsheets and automatically fill it into web pages. And it was fantastic 80% of the time. But for the rest of the time, it was just failing in the most miserable ways possible. Users were complaining. And when we went through the logs, it was one of the most laborious projects I've ever worked on. It was like so hard to understand what's going on. And we ended up having to build our own internal testing and debugging and tracing tools. And just by doing that process alone, we learned that we were not alone doing this. Everybody was having the exact
Okay.
same issues, wasting hours, days, and weeks just trying to debug their agents. So we built the debugging tools. We shared with some other people in the community, in the AI agents community in San Francisco. They loved it. And we
Mm.
decided this is probably going to be the enabling technology to make sure that the next wave of AI agents hits here faster.
Yeah, no, I totally agree. I think that I think at when I started getting to at the end of last year was, okay, what is an AI agent? Like, how do you even set one up, right? So AutoGen came out, I started using that, and then I know Crew AI is here, and it's like some people are kind of, a lot of people use ChatGPT, which is kind of an AI agent. But if you have set up a group of them, they can really do some powerful things. And like you're saying, it's nice to see what's going on in the background, and it can be a lot to debug and see what's actually getting, being produced in the background.
So here's how we think about the anatomy of an AI agent. So underlying all of your agents is usually a large language model, right? And the LLM is basically what powers the reasoning and workflow engines behind how the agent operates, picks its tools, understands which memories to query and how to do RAG, so on and so forth. And on top of that, every agent usually has a combination of tools and function calls. So at the very bare minimum, I would say an agent is at least an LLM plugged in with tools or function calls that identifies how to reason through objectives and patterns and solve problems by doing that. On top of that, we're able to take these two combined things and add other pieces of metadata onto it so the agents become more manageable and more easy to understand and debug, essentially. So the main thing is actually adding agent metadata. So understanding what your agent ID is, what data it has access to when it was created, what models it's using, so on and so forth. And on top of this, just having the history and understanding what data your agent's capable of seeing, whether it has external memories it can pull from, so on and so forth. These are two things that are highly underrated in the agent workflow because we all assume that agents start from scratch when you're just playing around with the OpenAI API. But actually being able to index and document what actions it's taken and what memories it has is a huge way stepping forward of understanding like how to steer these things in the right direction. And one huge aspect, and this is really popular with frameworks like AutoGen and Crew AI, is multi-agent tenancy. So essentially, you're able to stitch together multiple agents in a single run that solve different problems by either assigning them different tasks, different tools. It solves a number of issues, including parallelization. You're able to make sure that they hallucinate less because you're not mixing around context. And they're also becoming specialists. And that way, they actually perform more effectively and solve problems faster and safer.
I think if even for people that are just like are getting into AI agents, that was a lot of information that maybe you don't realize that's happening in the background. A lot of times you just set up the task that you want them to do, and then hopefully they perform it in the way that you want. So thank you for that presentation.
Mhm. Cool.
Yep. So I just want to say that I've used it. I think like last week I started using it. I mean, it was really simple. You just sign up on your website. It's free. And I know people might think, "Oh, I don't need an API key." It's free. There's nothing else that you need to do. Um, and I pip installed AgentOps, 2 lines of code, and it was running. And at the end, after I had a big group chat, I was able to see the dashboard, and it showed me everything I need. So I just wanted to say kudos to you for how simple and easy it was to set up.
So our basic philosophy behind agents is that you shouldn't have to create these insane frameworks just to stitch them together. Everyone's coming up with their own patterns right now. We don't know what's going to work and what will work and what's not going to work. So we have a very unopinionated yet magical implementation pattern that makes it super, super easy just to add observability, classifying your agents, what tools they have, all the metadata we talked about into an agent run. So I can show you off how we do this with
Yes.
our yeah.
Yeah, I would love to. They would love to see how they can get something running.
So AgentOps, our SDK is totally open source. A lot of backend features are you can do self-hosting if you speak to us, but essentially the way it works is you just pip install AgentOps and you run this agentops.init. And what we have right now is first-class integrations with a number of frameworks, including CrewAI, AutoGen, and Llama Index coming soon, as well as a few others down the line. So that way, instead of having to laboriously update and index all your code and add these custom traces and decorators and open telemetry, we just take care
Mhm.
of all of it for you. And that way, all of the abstractions, all the pain of implementing yourself is just, it goes away.
Like you taking care of that in the background to make this easier. Like I'm sure that I know that was a lot of work for you guys, but to make like the user experience that much better by not worrying about those things when because not to go on a side note real quick, but the thing about all these AI agents and these frameworks is they do update very frequently. So all of a sudden, what worked last week can break next week if you don't have, if you update. So to be able to handle that that's amazing. That's awesome.
Yep, exactly. So we were very, very intentional, understanding working very closely with the Microsoft team when we saw their AutoGen project come out, because we know this is going to be like kind of the next wave of how agents are implemented. So if you actually go to their documentation page, if you go to the agent observability tab, you're actually able to see that there's a few tutorials on how to do it. We're a full service provider with AutoGen. If you go to their notebooks, you're actually able to see how we do integrations with AutoGen. So essentially, it very, very much is the 2 line of code implementation. So all you have to do is add an API key. You can get an API key for free from the AgentOps dashboard. You just add it, and your session replays automatically start getting logged into the terminal. So for example, here, we see a session replay. I just provided an API key. You get a link here, and this link leads to your dashboard, shows you everything you need to know. And also at the end of the chat, it does show you it shows you the total cost. So one big challenge with the LLMs is that they're pretty expensive. So we made a very, very simple utility that when you finish running an agent ops run, you automatically get the cost at the end of in your session console.
That's really nice to see. That's a small little line, but that's really nice to know.
So what we made is a very, very simple dashboard to use. So if you go to agentops.ai, you can create an account for free. Again, just we have product management, project management. We have an overview dashboard where you can basically filter in and see exactly how all of the agents are running. So here's an example where I've across all my runs, I've spent about $16 in OpenAI and Anthropic and other credits. I can see how many of my sessions never completed and determine it, how many succeeded and how many failed. And I can also see session errors. So that way I can flag what agents are failing, which ones are working, and use that as a way to debug and fix what's going on wrong in dev and how I make them more reliable in prod. So for example, here, I'm going to load in a session where we used AutoGen for a run. So you can filter in by tags. So for example, here's an AutoGen tag that I just made. And here's a notebook that cost me almost $1. So you can see here that this never completed. It cost me 79 cents. And what's super convenient about this is that I can say, oh, I can see all the chats that happen with LLMs here. I can see the different event types. So I can see reply functions. I can see receive messages. I can see LLM calls, and I can see tools, which is suspiciously empty for this run. I can also monitor repeat thoughts. Repeat thoughts are this concept where agents tend to go in circles a lot and then they never complete. And then it ends up wasting a lot of time and a lot of money. So we're able to monitor for that and help you flag agents that might be going wrong in that sense.
It's this like I said, circular thought process, and it'd be very nice to know how that can be fixed and who's doing it, who's the responsible agent.
Exactly. Speaking of, we also handle multi-agent frameworks pretty gracefully. So, for example, here you can label each individual agent and you can flag them. So, for example, I have assistant agents, and I can filter in by that. I can see user proxy agents. I can filter in by that and see exactly what the agents were doing at any given point in time. So, if I look across maybe this user proxy agent, I can actually see a waterfall graph of all of the activity. So, I'm going to just go all agents
Mm.
for sake of brevity. So here I can see all the action calls that the agents have made. So for example, here, the agent received a message or executed a reply function, and then it made an LLM call. So I can see the LLM call here. It cost me a penny in GPT-4 credits. I can see the whole system prompt. I can see the completion and everything in between. And so that way I get actually like a detailed granular breakdown of what every agent's doing at any given point in time. And that way I can see where things are going wrong in the process. Additionally, in the near future, we're introducing time travel debugging. So one big challenge with these agents is they're very, very slow. For example, this agent took a very long time to complete. We can basically take this entire waterfall diagram. We can pin a certain point in time and then rewind the agent from that checkpoint and then run it, change some variables. And then that way we can see if it's able to complete the task. So I'm going to show a different example of a different framework. So this framework is called Crew AI. Crew AI is also a multi-agent framework. So here's a Crew AI run that I ran previously. It took me 9 minutes and 42 seconds to run it, and it ended up failing at the end of it. So what I can
Mhm.
use for is actually see why it failed and have an exact detailed log of what went wrong here. And I can also see the total LLM cost, which is quite expensive in the grand scheme of things. And again, I can also filter in by each individual agent. So for this Crew AI run, I spun up 3 different agents, one named a research analyst, one named a job description writer, one named a review specialist. And I can filter in each individual agent runs. I can see the tool calls, I can see the LLM calls, and I get a really nice fancy waterfall diagram at the end of it. So I can see exactly step by step how the agents were reasoning through things, using tools, searching the internet, delegating tasks to coworkers, so on and so forth.
Wow, that's amazing. That is so. I think the being able to, because I didn't quite realize is that you could replay from a location where it may have failed, and then kind of see what happened and debug from there. That's a nice addition to that to help us out.
So we're trying to build the tool we wish we had when we started building it. When we first started, it was the Wild West. Nobody knew anything. And now people are continuously frustrated on the same problems. Our goal is to make sure that nobody ever runs into those problems ever again. And we can build these super cool AI tools to market super fast.
Yeah, no, that's it. Normally, whenever you get too frustrated, you start to figure out ways to solve the problem, and you happen to solve a problem that a lot of people have. Maybe most people using AI agents. Yeah, awesome. Again, thank you so much for that demo and that presentation on how to integrate with AutoGen. Again, that was super simple and very easy to use. And I'll have a link for the source on how to do that in my GitHub in the description of this video. But I wanted to just kind of continue the conversation about AI agents. And where do you kind of see AI agents within like the next year or two?
Yeah. So when I think LLMs first hit the market, a lot of this stuff seems to have been a side effect. And then once people started building out demos, it became very, very clear that there's a whole path towards building agentic software that can be reasons for this. So if you're a developer and you want to make a bet on the future, you should always bet on the models only improving. So a lot of these, wrapper startups, they end up disappearing because we try to build tools that make assume the models won't get better. You should assume the
Mhm.
models will get better. You should assume that the reasoning power of the models will get better, and that way the agentic workflows will necessarily also improve. So that's step one, and this is what everybody here in the San Francisco ecosystem believes. A lot of OpenAI engineers believe. So you should really be betting on that. Second to that, you should always think about what kinds of use cases are very, very simple and could be automated. One big challenge right now is that it's very difficult to plug in different data types into your agents. So there's a lot of like ecosystem partners coming around here, chatting with PDFs, chatting with images, chatting with videos. And this comes with essentially you need to figure out how to like tokenize all these words and all the content that's in unstructured data forms and bring it to your agents.
Mm.
That's actually where the biggest challenges are rising right now with the agentic workspace.
Yeah, I think you brought up a good point there. And I think a lot of people, when they see AI agents, like, oh, is it solving my life? Like, can it solve everything for me? And it doesn't have to be that big, right? Like, you can take a task that maybe you do every day that takes you 10 minutes, but now you can have a simple crew or you can have a group chat that that does it for you in just a couple seconds, right? It doesn't have to be this elaborate thing all the time, right? That's here. They're here to like assist you and really help you. I think some people kind of get that misconception where it has to be this amazing thing that you build. It can be simple.
So one agent that we built internally, it's super, super simple. It's a Slack bot. And all it does is I give it a lead, like a company URL or somebody we want to speak to, so on and so forth. It just takes the URL, it scrapes the website all by itself, and then extracts all the information from that, make sure that it's correct, factually sound, and then inserts it into my CRM. And it's literally
Mm.
like the most convenient agent that we use in our company. It's like, it was very, very easy to build. It took maybe like an hour tops and extremely, extremely powerful because it's brought us a lot of business from doing that. So just thinking about what things are very simple and a human does that involves a lot of copy paste, a lot of data extraction, what can be automated and just brought into your current workflow. And that's where agents really kind of step into the play here. Just find very simple workflows, automate them one step at a time, make them reliable, and then your life is suddenly 10% faster, which is huge.
No, I totally agree. I mean, it's amazing what just taking something that's simple you do every day, or even most days, or some days, and then just being able to automate that, or like schedule it somehow so it's automated. I mean, that can be very powerful, and I think sometimes that can be kind of missed. How simple things can really be powerful. That's a great example. Thank you. And something I kind of get, I see a lot in my comments. I tend to use OpenAI because my machine only has like 8 gigs of RAM, so I don't like I can typically do like a Phi 2 model or even a recent Phi 3 model because my computer can actually handle it. And a lot of people say, I only want to use AI local model for free. I only want to use free local open source, some of them, AI models, and I don't want to use OpenAI. Kind of what are your thoughts on the quality of some of the open source models too versus OpenAI's like the recent 4.0 Omni model.
A lot of it seems to be a race to the bottom in terms of text in, text out models. So, for example, Mistral very quickly caught up to OpenAI, Llama very quickly caught up to OpenAI. And now we're kind of seeing like LLMs are becoming commodified in a lot of ways. And the thing that's going to really be unique about a provider is the way that they're able to capture different data sources and feed it to their models. So, for example, I expect that GPT-4o and the way that it manages voice inputs is probably going to say probably very close source for a long time. Um, and that said, local models are extremely powerful, but you have to think about the fact that when you're trying to automate things, what is your margin of error? Oftentimes, you really don't want a low passing rate. You need to either like A, turn it into a copilot program where you're okay with errors that you can correct, or B, make sure that you're picking the best model every time. I think in the short term, just pick models that are reliable with the expectation that LLMs are only going to get better. And that way, in the future, these things are going to become smaller, they can become faster, they're going to become cheaper. You can run them on your devices. There's going to be specialized hardware for this probably. Just focus on that because I think right now there's a lot of like interest in the local models, which is fantastic. But for kind of like most application purposes, I just rely and stick to what's best.
Yeah, no, I tend to agree with that. I know, and what you're saying, like, always expect them to get better. You know, I think there's some people that like, oh, it didn't do what I said. Maybe you could have just prompted it wrong. But some people have the tendency to think that they're just getting worse. If you just browse any Reddit forum on, you'll find somebody talking about that. But yeah, I mean, I think the bet, like you said, is that they're never bet against that they're going to get better.
Mhm.
I
I
totally
think
agree
that
with that.
one case for local and open source models is actually tool calling. So right now, GPT-4o and even the Claude class
Mm.
of models, they're not fantastic at picking out and deciding what tools to use. So there's actually a handful of open source models. There's a leaderboard from the Gorilla Lab at Berkeley, and they've published a model that's really fantastic at picking tools. I think it's comparable, if not better, than GPT-4 right now. So you should
Mhm.
consider that there are some open source alternatives that actually do beat the mainstream contenders.
Oh, okay. That's awesome. I think that really wasn't the case, you know, I would say at the beginning of this year or the end of last year. It was pretty much if you really want to have a function calling be any decent, you would just use a GPT model, right? There wasn't a lot of local open source models that could handle that. But you're correct that I've seen that they're getting better and there's more models that are capable of that.
Nexus Raven is one of these models that's performing super well with function calling. It's definitely worth checking out. Pretty underrated right now. But really, just by and large, open source, closed source, pick what's best for you and makes things the most accurate. So if you're interested in agent ops and basically building more reliable agents, getting observability, and making it easier to build these things, please give us a star on GitHub. We just crossed 1,000. Super exciting moment for us. We have a lot of stuff planned on the roadmap. So more integrations with agent frameworks. We currently do AutoGen, we do Crew AI, we have Cohere, LangChain, LiteLLM, Llama Index is coming out soon. We're also planning time travel debugging. I spoke about this earlier. Basically, be able to pause your agent execution runs, go back in time, save that state, and then continue from there. We're also creating like an agent leaderboard. That's kind of a little bit under wraps right now, knowing which agents are best at which tasks. We have a whole evaluation framework coming out soon. Like lets you basically see how do you rank your agents across different benchmarks, and are they ready for production if they pass certain standards and evaluations. We're also building a lot of other things. So for example, having cost management more easily baked into your agent runs. We have an open source library called Token Cost. This is definitely a cool library to check out if you want to manage your token prices better. So essentially what this is a giant cost calculator where we've taken over 400 LLMs, finding the price of them, and then make very simple Python utilities so that you can basically count and expect how much you're going to spend when you make OpenAI calls, Anthropic calls, Cohere calls, you name it. So this is a cool library to check out, also by AgentOps. We're also, if you're bringing these things from development or prototype to production, we're also working a lot more on CI/CD integration and checks. So basically having regression testing so you know when your agents are at a certain threshold you're happy with before sending it out to production.
Okay, that's awesome. Thank you so much for that roadmap. I'm actually excited about those integration checks for the pipelines. So and I think being able to have something like this in production, I think this will become very valuable, like especially for even smaller development companies where money or the output that you're producing is important, maybe more important because you don't have as much to as much capital to like move around with. So I think that's awesome, and thank you so much for showing that roadmap, and thank you for just showing us Agent Ops and how it works and how simple it is to integrate. And any of you can do that right now. I'll have the source on a sample project in my GitHub repository. I have in the description. And I just want to say thank you, Alex, for joining, and thank you so much for showing us what it's about.
Yeah, of course. It was a pleasure. Love to chat more about agents. If you want to get in touch, feel free to give us a star on GitHub and join our Discord. We're very active. We're happy to help you debug issues, brainstorm problems, solve hackathons, you name it. We are there to help.
All right. Thank you so much, man. I appreciate it. It was a joy talking to you.
Yeah,
Thank you.
likewise.